All right, guys, so in the previous video, you got to see an example of a function with a vending machine, all right, which is pretty cool. But let's get a little bit more now into numerical functions and what this means. And we're going to hold these same truths. So let's go over a couple of questions. Definition of a function. Well, if you paid attention, a function is a relationship between two variables, where one is the input, one is the output, and each input corresponds to exactly one output. Now, that doesn't mean that an output can only have one input or correspond to one input. That's can get a little tricky, but one input can give you exactly one output. We saw with Mountain Dew that two different inputs can give you the same output, and that's fine. All right. And so we've just reviewed the vending machine. Every function contains two variables. These variables are called the independent variable and the dependent variable. You can also call them the input and the output, or X and Y. But actually in this class, instead of calling them X and Y, if you see right here in the third bullet on the right, we're going to call it X and f of X. So this video is mostly about function notation. F of X. So rather than writing our functions y equals, for example, y equals 3x minus 4, this says f of X. This is not f parentheses X. This is not f times X. This is f of X. The function of X is 3x minus 4. For example, the function of the first button was to give you a Pepsi. All right, so right here, what's the function of 2? Or what is the value of the function at 2? Well, this basically means make 2 the input of the function. So if my function is 3x minus 4 and 2 is my input, you see that it says f of 2 right there. And let me go back, all right, to 3x minus 4. F of 2 would mean I'm going to substitute 2 for my input. So that says 3 times 2. Make sure you understand that when you substitute something, you are going to substitute it with multiplication. So that's 3 times 2, which gives me 6, minus 4 will give me 2. So f of 2 is 2. Let's go to Desmos real quick to see how that works. All right. So with Desmos, let's say my function f of x is 4x minus 10, and I give you some instructions right here on how to use Desmos. All right. Well, if you use function notation f of x, then Desmos is automatically going to evaluate for you, right? I could say f of 3, and it is automatically going to tell me that its output is 2. Now I can do mental math to work that out. 4 times 3, 12, minus 10, 2. So that's how a particular input, 3, gives you one output, 2. It'd be really weird if it gave you an output of 2 and then somehow magically it could give you an output of 5. That would be impossible. Numbers only work one way, so it couldn't work out like that. We can use this. We can extend this concept to more complicated functions. Here's something that you call a quadratic function, which you're going to look at much later in the semester. And don't be afraid. It looks kind of complex, but it's not bad at all. All right. So this function is g of x. We can call them different names. G of x equals 4x squared minus 2x plus 3. If I were to evaluate g of negative 2, well, Desmos tells me its value is 23. Let's talk about how that works out. G of negative 2 means let's substitute, well, let's say 4 and substitute a negative 2, which is going to be squared, subtract twice the amount of negative 2, and add 3. Well, Desmos is not going to tell me anything right there because I've got an equal sign. If I take this away, it's going to evaluate it for me. It tells me 23, and you can work that out in your head as well. Order of operations is going to tell you that you need to first square the number negative 2. So negative 2 quantity squared is 4. 4 times 4 is 16. Then you're going to subtract, or then you're going to combine it with negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4. So we've got 16 and a positive 4, which gives me 20. Add 3, you got 23. So that's how that works out. Let me just make it a little more explicit for us. So that's 4 times, we said negative 2 quantity squared is 4. All right. And then we're going to say negative 2 times negative 2 gives me positive 4. And then we're going to add 3. See how it still gives me 23? I can simplify that to say 16 plus 4 plus 3, combining those 3 parts, and I get 23. That's function notation.